All right, polar quiz review session. We're covering sections 10.7, 10.8. So 10.7, you might recall, we've got a whole lot of the plotting of the points in polar form. We also have a whole lot of conversions back and forth between, given a point in rectangular form, switch it to polar, polar, switch back to rectangular, and then we could also do that with equations. So that was 10.7. 10.8, that's when we had the actual polar curves that we were sketching. The two types that we focused on were the Rose curves and the Limassol. So that being said, let's go ahead and just jump right into it. You're going to see a problem like this on tomorrow's quiz where you're given a polar graph and you're given a point that's plotted. So our job is going to be to identify the coordinates of point P, but if we can do it at a very specific rate here. So again, if we're looking at this and we need to identify a positive angle and a positive radius. Again, I'm going to begin by looking at how far we went out. So it looks like we went out 1, 2, 3, 4, 5 units. So my positive radius of 5. So what that would be like is if we went out on the polar axis 2, 3, 4, 5 to this point, and then in the positive direction, I'm rotating all the way around. So to determine how far it is that we're rotating, again, just using my knowledge of the circular rotations in general, it looks like that we're going to rotate around 5 pi over 4. So if next I'm looking at having a positive radius, we already know that's going to be positive 5, but a negative angle. Again, the positive radius is still going to be 5, but what if we got there by rotating this direction instead? So again, we went out our 5 units, and then we're now rotating in the negative direction. So if we were to look at it this way, we went 5 for the radius, and then negative 3 pi over 4 for my negative angle. Part C, we're asked to figure out a negative radius and a positive angle. So I know that some of us are struggling a little bit with the negative radius, but again, in terms of the negative radius, no secret as to how we're getting there. So I know that probably the easiest way that a lot of us have been thinking about this is that we're just going to go to the left, 1, 2, 3, 4, 5, because that's on the polar angular line of 0. And I know that, again, that seems confusing, but once we are here in that negative 5 direction, all that we're left to obtain, if I'm looking for a positive angle, remember positive angles are going to be measured clockwise, we would just figure out our rotation in this direction. So it looks like negative 5, and it appears that we're just talking about pi over 4 as the remaining positive angle. Similar to that, in part D, if we're talking about a negative radius, again, we're talking negative 5, and a negative angle, that means, again, same movement to where I went to the left 5 units, and now in the negative direction, we need to rotate all the way around, which is full circle almost, except for that pi over 4. So we would say in that negative direction, we're going negative 7 pi over 4. Again, another way that we could have approached this from the negative standpoint, oops, I got rid of P on accident, we could look at it from the standpoint of, okay, if I went out 1, 2, 3, 4, 5 units, and I rotated to this point, and I got here, if I'm simply reflecting back over, that's what the negative radius is going to do. It's not going to put me on this angular line, it's going to put me down here on this one. Again, I just think it's easier for us to think in terms of, okay, we have a negative radius, we're going to move to the left, not the right. But this is 100% absolutely going to be on tomorrow's quiz. All right, second question that we have, we want to write 2, 120 degrees in rectangular form. It's currently in polar form, which means that we're given r and theta. So crucial to our success is that we have to be able to identify that r is 2, theta is 120 degrees. Once we know that those, I think a better way to say it, that those are our values, now we can utilize this into our conversion. So we know that x is equivalent to r cosine theta, and that y is equivalent to r sine theta. So now it becomes substitution, and we can say that x is going to be equal to r, which is 2, times the cosine of theta, which is 120 degrees. So now it's going to come come down to our reliance on understanding, knowing that unit circle. So when we're looking at this, we have to consider that the cosine of 120 degrees is -1/2, and 2 times -1/2 is -1. So we know our x term, we have our x value. Jumping over, we're going to do the exact same thing for the y term. So y is equal to r, which is still 2, times now the sine of theta, which is still 120 degrees. So when we consider the unit circle, the sine of 120 degrees, I believe that's going to be √3/2. So we're left with 2 times, again, √3/2, multiplying that out. The 2's are going to eliminate, and y is equivalent to √3. So once we know x and y, I can now put this together in my coordinate point, regular or rectangular form of x, y, -1, comma, √3, and we're done. Second problem on this slide, number 3. Now we want to write the point -3, -3 in polar form when theta has to be between 0 and 2 pi. So I'm given rectangular, so I currently know x and y. So just like before, x is -3, y is -3. Not that it's coming up right now, but we can look at this point and say, okay, -3, -3, okay, I'm in the third quadrant. So again, not that that's crucial at this particular moment, but again, we should probably take stock in the fact that yes, we are absolutely located in that third quadrant. My goal is to be in polar form. So remembering, of course, that polar form is r comma theta. That really just means that I have to separately figure out r and theta. So the way that we're going to go about figuring out r, again, another conversion formula here, r squared is equal to x squared plus y squared. So going to work, we're going to say that r squared is equal to, substituting in, we're saying that x is -3, and we're saying that y is also -3. We're plugging this in place. So if r squared is equal to, I know that -3 squared is 9 in both cases, so if r squared is equal to 18, square rooting both sides, again, r is equal to square root of 18, which is 3√2. Once we have r, again, we're successful there. Now I need to go to work on theta. So my last conversion that we haven't used yet is that the tangent of theta is equal to y/x. So again, substituting in, we can now say that since y is -3 and x is -3, the tangent of -3/-3 is really the tangent of 1. So when we apply the tangent inverse, we can say that theta is going to be equal to the tangent inverse of 1, which is all a fancy way of asking where in the unit circle is tangent equivalent to +1. And we know exactly where that's going to happen. Again, on the unit circle, we know it's going to happen here, we know it's going to happen here. So a little less hand-wavy in the actual information here. We can say that that's going to happen specifically at pi/4 or at 5 pi over 4. So now the way that we determine which angle it absolutely is going to go with, because again, we don't want 2 answers, we want 1 answer. We go back to, at the beginning, we said that, yeah, -3, -3, that's in the third quadrant, which means we're talking about this point, which means we're not talking about pi/4, but instead about 5 pi/4. So if I know r is 3√2 and theta is 5 pi/4, I simply put them together, and now I have my polar coordinate, and we're done, and we can move on. All right, next, number 4, it says that we want to write 3x plus 5y equals 2 in polar form. So this, again, when it comes to these conversions, it's probably going to feel a whole lot like substitution, which, again, I feel like that's a good thing if we think this is substitution, because, frankly, substitution is pretty easy. So when I'm rewriting this problem, you'll notice that I'm just leaving space for x and y. And the reason is that my conversion tells us that x is just simply r cosine theta, while y is simply r sine theta. So if I were to rewrite these problems, by this problem, I should say, by substituting in, the last thing that we can do is we can group the entire left side and think about what factors out. And the answer is that an r is going to factor out the whole thing, leaving us in the interior with 3 cosine theta plus 5 sine theta is equal to 2. And remember what our goal is to get r completely isolated. That means that I'm going to divide both sides by 3 cosine theta plus 5 sine theta. If we did that on the left, we're going to do it on the right. So 3 cosine theta plus 5 sine theta. beauty of this is that on the left side they cancel. On the right side, I'm left with my answer. So r is equal to this giant mess on the right side of 2 over 3 cosine theta plus 5 sine theta. And again, that would be our final answer. Again, we know that we're done when we've isolated for r. Again, when we change from rectangular to polar, that means that we have to get rid of all x's and y's, and we have to equate to all r's and thetas. Number 5, similar problem. This time we're in polar. We want to go to rectangular form, so I need to convert r equals 4 back into rectangular form. Now, if we're to consider our list of conversions, again, x is equal to r cosine theta, y is equal to r sine theta, tangent of theta is equal to y over x, and r squared is equal to x squared plus y squared, we don't actually know, or I shouldn't say no, we don't actually have any conversions specifically for r. So what I mean by that is that we need to somehow, some way, get r to be r squared. So in order to do that, there's really 2 ways of going about it. Number 1 is we could just simply multiply both sides, times r, which is going to give me r squared now times 4r. Which is good news on the left side. We can substitute x squared plus y squared in place, but bad news on the left side because I still have an r. So instead of doing it that way, let's consider the other way, and that is, couldn't we just square both sides? Meaning, could we rewrite this as r squared is equal to 4 squared? The answer there, of course, is yes. R squared is equal to, I know that 4 squared is 16, at which point now we can consider, again, my conversion and say that r squared is simply now x squared plus y squared is equal to 16. Remembering, of course, what my goal was, to get rid of any r's and thetas and to just have x's and y's, and we've done exactly that. Our next one, number 6, we want to convert r equals negative 3 secant theta to rectangular form. So I know that some of us see the secant theta up there, and we initially panic and we start to freak out and think that something's going wrong. And that's really, hopefully, couldn't be further from the truth. There's nothing wrong with this problem. It's just that we want to rewrite it to where, again, if we don't like secant, we can rewrite it as 1 over cosine theta. So now I'm considering how do I get rid of this? And I suppose what I'm going to encourage you to consider is that we know that x is simply equal to r cosine theta. So this is what we're going to play off of, is if I can get to r times cosine theta, that means that we have a substitution. So what I'm getting at is that could we simply multiply both sides times cosine theta? The main reason is that on the right side, this is going to cancel out. On the left side, it's kind of a secondary reason, but also incredibly important. That's going to give us r cosine theta on the left side is equal to negative 3. Remember, like we just said, r cosine theta, that is simply x. So I can say x is equal to negative 3. And remember what our goal was, to get rid of any r's and thetas, and we've done that. We got back into x's and y's. Again, this particular problem did not have a y value. That's okay. So, on tomorrow's quiz, one of the things that we want you, I should say, to be aware of is that, again, in order to prove to me, show to me, whatever, that we got this video watched, I want you to draw in a rose curve. So 4 petals is what I was thinking. So if you were to sketch in this rose curve, again, let's not overdo it, overthink it. It's going to look something like this, but we're going to label each of these significant points. We're just going to label it as simple as possible. Let's go with P, L, H, S. Again, as you can obviously see, I'm not very creative, but this is the way that that's supposed to look. All right, I see that. I'll know that you watched this video. Okay, so next, in number 7, we want to identify the type of graph for the following equations. If it's a rose curve, we want to identify how many petals, and if it's a limacon, we need to specify which type. So, if we're to take a look, excuse me, if we're to take a look, again, the way that we can determine the difference between rose curve and limacon is whether or not it's straight multiplication or if it's a sum or difference. If it's straight multiplication all the way across, we know it's going to be a rose curve. If we see any type of addition or subtraction taking place, like in A or C, we know that that's going to lead to a limacon. So I've got to stop the podcast here and upload. We'll jump right back in here with number 7.